An introduction to hypothesis testing. A hypothesis test is a statistical procedure that involves formulating a hypothesis and using sample data to decide on the validity of the hypothesis. In this chapter, we will focus on hypothesis tests about population means and proportions. In order to test any hypothesis, even non-statistical hypotheses, you need three basic elements. First, the hypotheses, both the hypothesis that you are testing and the alternative hypothesis, which is the opposite of the test hypothesis. Second, you need an unbiased test statistic. That's a measure that you plan to use in order to evaluate the hypotheses. And third, you need a rejection rule, a rule that you will use to ultimately decide if a hypothesis should be rejected. Here are two non-statistical hypothesis examples. Example 1. The hypothesis is I should be admitted to Harvard Law School. The alternative hypothesis, I should not be admitted to Harvard Law School. The appropriate test statistic that they use for evaluating this hypothesis is your LSAT score. The rejection rule could be some hardcore cutoff that they use to decide on admitting students to Harvard University. Example 2. The hypothesis, O.J. Simpson is innocent. The alternative hypothesis, O.J. Simpson is guilty. This example is referring to O.J. 1, not the not-so-infamous memorabilia heist. For that first O.J. Simpson case, the test statistic was the jury of 12 of his peers. The rejection rule, if 12 of 12 jurors ruled that he is guilty beyond a reasonable doubt, then they ultimately rejected his hypothesis of innocence. The basic goal of hypothesis testing is to try to find sufficient evidence to reject a claim. It is exceptionally tough to prove that a claim is true. A good but probably warped example that comes to mind would be thinking about a not-so-faithful significant other. While it's extremely tough to prove that someone is definitely faithful, proving something along this line would require a camera following them 24 hours a day. However, it's much easier to prove that the claim of being faithful is actually false, whether it's unfortunate telephone bills or emails or other evidence like that can come to light. One piece of evidence could easily prove that a claim is false, but it takes a lot more time in order to prove that a claim is true. Following this line of thinking, our main goal in hypothesis testing is to set out to see if we can find sufficient evidence in order to reject the hypothesis. In order to test a hypothesis, you must first find the test statistic and rejection rule that is appropriate for evaluating your set of hypotheses. In other words, you wouldn't want to use O.J. Simpson's LSAT score in order to prove or disprove his innocence in a criminal trial. Once you've found the appropriate test statistic and rejection rule, we should note that all hypothesis tests will always end in one of two ways. Case 1, you conclude that you must reject the null hypothesis. This is the same as concluding that you have found sufficient evidence to prove that the alternative hypothesis is true. Or second, you can conclude that you do not have enough evidence to reject the null hypothesis. This is the same as concluding that you do not have sufficient evidence to prove that the alternative hypothesis is true. Statistically, hypothesis testing is used to determine whether a statement about a population parameter should or should not be rejected. The null hypothesis, denoted H sub 0, is a statement of the basic proposition that is being tested. This statement is not rejected unless there is convincing sample evidence that it is false. The alternative or research hypothesis is denoted HA. This is the opposite of the null hypothesis. This statement is accepted only if there is convincing sample evidence that this statement is true. Using this thought process, if we want to test the validity of a claim, and you want to find evidence to contradict a claim, that claim should be stated as your null hypothesis. Again, if you are trying to reject a claim, then the claim should be stated as your null hypothesis. If we go back to slide 6, case 1 of the possible ways that a hypothesis test ends is based upon us finding sufficient evidence to reject a null hypothesis. For this reason, if you're trying to reject a claim, that claim should be stated as your null hypothesis. If you wish to prove that a claim is true, then you should state that claim as your alternate hypothesis. Returning to slide 6, if we reject the null, this is the same as saying that we have proven that the alternative is true. Therefore, if we wish to prove that a claim is true, we should state this claim as our alternative hypothesis. Claims that test whether the mean is equal to a specific value must be stated as the null hypothesis. On this slide, we have steps for testing hypotheses. For every hypothesis test that we conduct in this course, we will continuously return to these 8 steps to guide us in the process. In step 1, we determine the null and alternative hypotheses that we are testing. In step 2, we randomly select a sample to test our hypotheses. We should specify our sample size and the level of significance for our analysis. In step 3, we should research to find the appropriate test statistic and rejection rule for our analysis. Before we begin this research, we should note the following. First, we should note our null hypothesis. Second, our sample size. And last, we should list any population information that we know, such as the population standard deviation. In step 4, we specify the test statistic that we will use to test our null hypothesis. In step 5, we simply state the rejection rule that we will use for testing our hypothesis. In step 6, we use our sample data and compute the value of our test statistic. In step 7, we use the value of our test statistic and the rejection rule to determine whether we should reject our null hypothesis. And in step 8, we state our conclusion in layman's terms. Even though these steps seem rather extensive, if we follow the same steps for all hypothesis testing, it will greatly simplify the process. Since hypothesis tests are based upon sample data, not the entire population, we must allow for the possibility of errors. We define a type 1 error as rejecting the null hypothesis when in reality it's actually true. We can think of this type of error in a judicial sense as convicting an innocent person. Remember with our judicial hypothesis test example that we previously stated, the null hypothesis was that a person was innocent. If you think of it in this sense, you would really want to be cautious and not reject someone's claim of innocence unless you have found overwhelming evidence to do so. The person conducting the hypothesis test must specify the maximum allowable probability of making a type 1 error. This will be denoted as alpha throughout our hypothesis testing sections. Alpha is referred to as the level of significance. Typically, we want alpha to be small because we want there to be a small chance that we make an error if we decide to reject someone's null hypothesis. In a business sense, if a company makes a claim that is published and we collect sample data to test out this claim, we would not want to reject their claim and publish this rejection if it is possible that we're in error. This could lead to lawsuits and also be costly. Therefore, we should always make sure that that alpha value is relatively small and be very cautious before we ultimately decide to reject a null hypothesis. A type 2 error is defined as accepting the null hypothesis, but in reality, it's false. In general, we can't control for the probability of making a type 2 error denoted beta. Statisticians avoid the risk of making a type 2 error by using the phrase, "We do not reject H0," instead of saying we've accepted H0. An example, going back to our judicial example, we usually don't say that we accept a person's claim of innocence. Instead, we say we could not find sufficient evidence to reject their claim of innocence. Many people believe that OJ case 1 was a type 2 error. In that case, They're saying that they failed to reject his claim of innocence, but many people believe that in reality, that claim was indeed false. Statisticians usually prefer to not convict an innocent man opposed to letting someone go that they kind of suspect is actually guilty.